Had you stopped an educated man or woman in the street in the middle of the 19th century and asked about the origins of life, they would certainly have mentioned the Bible and maybe scrummaged around in their pocket or purse for a copy of the Great Chain of Being. This set out a familiar hierarchy: God, his angels, man, and then the animals, the plants, and then the inanimate rocks, all layered in orderly strata of diminishing intelligence. Since the Creator was perfect, everything needed would have been created already. There would be plenitude and continuity, a comfortable notion with a long history, with a place for everything, and everything already in its place. However, thanks to Darwin and Mendel, things were about to change in a revolution that matched the Copernican one of the 17th century. Developments in microscopes were to trigger new interests in the cell and its workings, in heredity. Remember that there'd been selective breeding of animals for millennia. Soon it was clear that the seed of inheritance lay in the nucleus. Theodore Bovary suspected the chromosomes, and when Mendel's work was rediscovered, that was confirmed by Walter Sutton, working at Columbia University in New York City in 1903. Sutton used grasshoppers as experimental creatures. It was Columbia where the next major steps in understanding came from a small team and a tiny fly. The team had been set up round about 1907 by Thomas Morgan and comprised Calvin Bridges, Arthur Sturtevant and, for a while, Muller. Morgan had previously conducted studies with pigeons, rats and mice, but soon realised the potential of Drosophila. The tiny fly was easy to keep and prodigiously fecund, and just a handful of chromosomes. He started a study in the now famous fly room at Columbia of the naturally occurring mutations in the fly. A major landmark was when Sturtevant came up with the technique for locating the mutations on the fly's chromosomes and actually making a map. The team were to publish The Mechanisms of Mendelian Heredity in 1915, based on this work. It was widely regarded as the first book to fully reconcile the chromosome theory with Mendel's discoveries. It set the path for genetics for the next half-century. Muller, a New Yorker from the Bronx and a middle-class background, had won a scholarship to Columbia in 1907 and graduated in 1910. Returning to Columbia in 1912, he had played his part in the book and was then tempted away by young Julian Huxley in 1915 to work at the Rice Institute in Houston, Texas. Huxley left after just a year because of the war, leaving Muller to take on far more teaching than he cared to do. Muller persuaded his school friend and fellow scientist, Edgar Altenburg, to join him at Rice, and Altenburg spent the rest of his career there. A hint of the prospect of a permanent appointment had Muller back in New York in 1919. When this failed to appear, he found another temporary appointment at Austin, Texas in 1920. But before that he spent some time at Woods Hole with Altenburg, where he seems to have struck upon the CLB method that gave a very sensitive measure of mutation rate that might be useful for measuring the effect of temperature on the mutation rate. something that he and Altenberg had been investigating for a while. His rootless life seemed destined to last, but the 10 years at Austin were far more productive and turbulent than he could ever have expected. In 1922, the two of them visited Europe. Muller himself went to Germany and Russia. Useful contacts, it was to prove later. On his return, he married Jessie Jacobs, a mathematician, and in 1924 they had a child, David Eugene. Professionally, he developed an interest in twin studies, but mutations were never far from his mind. In 1923, he started using radiation as a tool to weaken cells and expose their genetic deficiencies. Although he had his new CLB test available, he did not think of checking whether the radiation caused any mutations. So convinced had he become that spontaneous mutations were a result of temperature-driven chemical processes. It was not until late in 1926 that he finally got around to looking for effects of radiation. He immediately found them and reported in a science paper in 1927 an increase of 15,000% in the frequency of mutations in comparison with controls. It promised, at the very least, a copious supply of new mutations to study in the laboratory. Mind you, even some of his colleagues were sceptical. Very few details of the methods were given. When Morgan first heard about the 15,000% figure, he said, "Now he's done it, he's hung himself." But far from it. Muller had struck gold. His first amplification of the science paper was presented at an invited address at the 5th International Congress of Genetics, held in Berlin in September 1927, and it caused a sensation. Man could modify his precious genetic material at will, giving him power to speed up evolution. He went to Berlin a virtual nobody, but returned to the USA something of a celebrity. However, things started to fall apart in 1931. His marriage to Jessie hit a bad patch, probably because of his increased workload, and after attempts at reconciliation, it soon ended in divorce. His working relations at Austin with key colleagues began to fragment, and critical comments from other workers seemed to undermine the very core of his work. To make things worse, he chose this moment to become an active supporter of the National Student League, a left-wing organisation which the FBI kept a close eye on. He even went so far as to write some articles for its newsletter, The Spark, named in homage to Lenin. The university took a dim view of it all. In a bizarre and maybe half-hearted suicide attempt in January 1932, he wandered off on his own with a bottle of sleeping pills into the hills around Austin. A search party of his students found him the next day, dazed and muddied, but still alive. Whether it was a cry for help or not, help anyway came in the form of a Guggenheim Fellowship that would take him away from the toxic atmosphere of Austin to Europe and Russia. And there was even the scent of a permanent post. His exile was not a total success. He was in Germany for a year before he became aware that a left-wing reputation might well not be a recommendation in the new Germany of Adolf Hitler. He moved to Russia for a while, but as fate would have it, it was the period where Trofim Lysenko and his perversion of genetics held sway. Muller was a vociferous opponent of Lysenko, just when opponents of the Russian were mysteriously disappearing. He chose a bad time to send his latest eugenic work out of the night to Stalin. The ruthless dictator was not apparently amused, and Muller received heavy hints that he should leave. This was easier said than done, but Muller confected the idea of going to Spain to fight in the Civil War as a cover, and this he did in April 1937. It worked except for the fighting. Muller spent much of his time trying to recover blood from cadavers in the hope of recycling it for the living. It didn't seem to work, and he stuck the administrative chaos that seemed to be endemic in the Republican side for just 6 weeks, and then quickly made his escape to Edinburgh, flies and romance. The Institute of Animal Genetics had been set up in 1919 by F.A. Crewe, and Morgan and Sturtevant had provided them with a starter pack of Drosophila when they visited in 1922. Muller was able to take over this small team and do some useful work, which included a demonstration that UV radiation caused mutations, perhaps an early hint that DNA might be important. Towards the end of 1938, he met and fell for Theodor Kantorowicz, a German technician of Jewish descent in the Institute. They married in May 1939. War was declared in September, and as it wore on, the two found it increasingly difficult to function. Muller, as an alien, had his movements restricted. The blackout made working with the flies difficult. They decided to return to the USA. They took a plane down to Lisbon and then the Clipper seaplane to New York. This went surprisingly smoothly until Muller realised that he'd not seen his treasured Drosophila, the culture, for some time. Panic reigned in the flying boat until a steward found a box labelled bread with the flies in it. It was in the pantry, of course. They left with no idea about job opportunities for an alleged communist who'd worked in Russia. The best he could do was Amherst, a liberal arts undergraduate-only college where Harold Plough, an old friend and colleague, managed to do some Drosophila research. Plough recommended Muller for a temporary research associate post. It didn't last long. In 1944 they had a baby. By 1945 he was told that the post would end in the summer. So at 54 he had new responsibilities and was looking for a job again. This time it wasn't so bad. A contact in the Rockefeller Foundation recommended and funded him for a research professorship at the University of Indiana before the year was out. The family moved to Bloomington, bought a house and settled down in some security to work on the flies again. Life, though, had at least one more surprise for him. One morning, in 1946, Muller received a phone call from a New York journalist telling him that he'd been awarded a Nobel Prize. He received the medal and scroll on the 10th of December from King Gustav. On his return, he took up his research again with a good flow of fellow students and postgrads, because of the prize perhaps, but became increasingly involved in the public debate about the risk of fallout from nuclear testing. His concerns were that this would place a burden of mutations on the human race, which would be cumulative. Not everyone agreed with Muller's analysis, but at the very least, some people became attuned to the idea that non-hereditable effects might possibly be non-threshold too. Muller was clearly influenced by his father, Hermann. Hermann Sr. was just embarking on a career as an international lawyer before being recalled from Stuttgart to play his part in running the family business when his father, Nicholas, suffered a stroke in 1873. The family business was casting metal clocks and statuettes, but Hermann Sr. cultivated a wide range of radical interests. He did much, according to Hermann, to give his son a strong sympathy for the working class, for oppressed people, and for internationalism, together with the scepticism of the righteousness of established governments and a hatred of imperialism. When Hermann Sr. died in 1900, Muller's mother Frances continued with this liberal theme. Hermann Jr. attended local schools, and it was here that he met Edgar Altenburg, who persuaded him to become an atheist, and later, as they progressed to Columbia, to join the Intercollegiate Socialist Society. We know that he was in trouble in 1932 with his membership of the National Student League and the Spark. His letter to Comrade Stalin in 1936, promoting the ideas in Out of the Night, clearly expressed his sympathy for and pride in Soviet achievements. He never really recanted. He remained an implacable opponent of Lysenkoism. However, he went so far as to say that, bad as the effects of nuclear weapons testing were, they were justified if they were required to avert the consequences of Soviet totalitarianism and slavery. So he went quite a way towards it. In his early years at Indiana, he was hauled up before the House Un-American Affairs Committee because his name had been associated with a Soviet agent, Alfred Kantorovich. It turned out that this was an error. The Soviet agent had the same name as Thea's father, a retired and respected professor of dentistry. The confusion amicably disposed of, the committee welcomed a chat with this distinguished scientist. And the papers reported the next day that Muller had condemned Reds and thought that they should not be allowed to teach in schools. Muller himself summarized the eugenics dilemma in a sentence in his lecture delivered in Columbia in 1910. Improvident, ignorant, reckless and selfish people, the dregs of the cities, are breeding like veritable disease germs, and the people of the cultured classes are not maintaining their numbers. He believed that races and civilizations had degenerated because they no longer had the vigour of barbarians, which results from natural selection. His remedy at the time was voluntary or otherwise sterilisation of the feeble-minded and habitual criminals. In his later writings, he essentially maintained this position, but doubts grew in his mind that sterilisation alone would be effective. He also thought that socialism was a precondition of achieving eugenic utopia. He dissociated himself from the mainstream eugenics movement because he considered it racist and white supremacist. Much later, he was a supporter of eutellogenesis, or his preferred term, germinal choice, a program of the collection of sperm from great men for artificial insemination of suitable women. Whether we really needed more great men, or geniuses, was a question that was not addressed. Perhaps that was self-evident to a genius. Eugenics slipped out of fashion after the war as people realised the full horror of what it might lead to. I've only touched on the impact that Muller had on genetics in general. Certainly, he was a difficult man with an almost obsessive interest in priority in his research, and neurotic and touchy in his personal relationships. He had many admirers as a scientist, but was not well liked. He was not a good teacher of undergraduates, but he made so many contributions in so many fields related to genetics, such as evolutionary biology, that he was an inspiration to people close to him. His radicalism had made him a hero to some, on a par with Robert Oppenheimer, with the same villain of the USAC, but maybe tempered by his support for eugenics. His legacy, his main claim to fame, is forever associated with the ability of radiation to cause mutations. Yet this is not entirely secure. In the early years, it was thought that, provided a threshold dose was not exceeded, the somatic risk from radiation was, in all but the worst cases, effectively zero, while Muller established that genetic risk had no lower limit in flies. After the Japanese bombs, it became apparent that this was no longer correct. Somatic cancer risk was important and the later dominant. There was no threshold. It became accepted that using one measure of detriment associated with radiation, the genetic component consisted of no more than a few percent of the somatic one. And even this is a projection from animal experiments, since there is still no human evidence of hereditable damage. Small wonder that ICRP consider the evidence requires review. So, Muller's work remains challenging almost a century after he did it.